Assalamualaikum and good day to our lecturer and fellow friends. Engineering mathematics is a fundamental subject in civil engineering because it provides important tools for analyzing, modeling, and solving engineering problems related to structures, transportation, and construction systems. One of the key concepts used in civil engineering is differentiation, which helps engineers study rates of change and optimize system performance. In this project-based learning report, our group focused on the application of differentiation into engineering-related scenario, which are the fuel efficiency of an engine and the cooling behavior of a machine component. For the first case, a mathematical model is used to analyze the relationship between vehicle speed and fuel consumption in order to determine the most efficient operating speed. This is important for engineers when designing vehicles that can optimize fuel usage and reduce operational costs. In the second case, we analyze the cooling process of a machine component. After shutdown, using an exponential function by determining the time when the temperature reaches its maximum value. Engineers can identify as a safe delay time before handling or servicing the component. Through this project, differentiation techniques are applied to determine rates of change and maximum values, which are essential in making informed engineering decisions. Thank you.
Hi, Assalamualaikum. My name is Aiman Arshad. Okay, our problems is the problems that we get that we need to solve is fuel efficiency of an engine. A prototype vehicle is tested to evaluate its fuel efficiency at different speeds. The relationship between fuel consumption, which is equal to CV, measured in kilometer per length, and vehicle speed V, measured in kilometer per h, is given by the mathematical model. Engineers aim to identify the most fuel-efficient operating speed for the vehicle, which number 1, determine the rate of change of fuel consumption with respect to speed when V equals to 15 km per hour. And number 2, find the speed at which the fuel efficiency is maximized and explain the engineering significance of this result. Problems Part 2. Cooling of a machine component. After shutdown, the temperature of a machine component varies with time according to the equation, where number 1, T is the temperature rise above ambient temperature. Number 2, T is the time in minutes. Engineers need to determine the time at which the component reaches its maximum temperature before it begins to cool down. This information is important for establishing a safe delay time before handling or servicing the equipment. Number 1, determine the time T at which the temperature reaches its maximum value and calculate the maximum temperature rise. Number 2, digital task. Plot the graph of TT for 0 to T to 15 and indicate the maximum point to verify your answer. So as you can see, here are the slides that we explain the mathematical method that we use to need to solve our case study 1 and also case study 2. Which is case study 1 is a fuel efficiency of an engine, and case study number 2, fuel efficiency of an engine 2, but in the temperature model. Alright, that's all. Thank you.
My name is Nazura Akila, matrix number AA250034. Today I will explain our digital solution steps for 2 engineering problems using differentiation. First, we look at the fuel efficiency of an engine. The mathematical model is written as C of V equals 100V divided by V squared plus 25. In equation form, C of V equals 100V divided by V squared plus 25. Here, V represents speed in kilometer per hour, and C of B represents fuel efficiency in kilometer per liter. To find the most efficient speed, we differentiate the function using the equation rule after differentiating and simplifying, we obtain C prime of V equals negative 100 V squared plus 2500 divided by the quantity V squared plus 25 all squared. To find the maximum fuel efficiency, we set the derivative equal to 0. So we solve negative 100 V squared plus 2500 equals 0. Rearranging gives V squared equals 25. Therefore, V equals 5 km per hour. This shows that the maximum fuel efficiency occurs at 5 km per hour. Differentiation helps engineers determine the optimal operating speed to reduce fuel usage and operating costs. Now we move to the second case study, which is the cooling of machine component. The temperature model is written as T of T equals 120 T multiplied by e to the power of negative 0.3 T. Here T is time in minutes and T of T is the temperature rise in degrees Celsius. To find when the temperature is maximum, we differentiate it using the product rule. After simplifying, we obtain T prime of T equals to the power of negative 0, obtain 3T multiplied by the quantity 120 minus 36T. To find the critical point, we set the derivative equal to 0. Since the exponential function is never 0, we solve. 120 minus 36T equals 0. Solving this gives T equals 3.3 minutes. Substitute this value back into the original equations give. T of 3.33 is approximately equal to 147 degrees Celsius. This means the maximum temperature occurs at about 3.33 minutes before the components begin to cool down. This helps engineers determine a safe waiting time before handling the equipment. In conclusion, the differentiation allows engineers to find maximum values, optimize system performance, and ensure safety in real engineering application. Thank you.
Now, I will present our final answer and the interpretation of the result for both problems in group 13. For problem 13.1, the fuel consumption model was differentiated to find efficiency behavior. The maximum fuel efficiency occurs at 5 km per hour. Mathematically, this is the maximum point of the function. From an engineering view, although this speed is not practical for real driving, the model helps engineers understand efficiency, trends, and design better operating range. For problem 13.2, the temperature model was differentiated to find the maximum temperature after shutdown. The maximum temperatures occurs at 3.5 minutes, with temperature rise of about 149.97 Celsius. This shows that the machine becomes hottest a few minutes after shutdown and not immediately. This is important for safety planning, maintenance timing, and burn prevention. Overall, these projects prove that differentiation is essential in engineering because it helps identify maximum efficiency, critical safety points, and supports better engineering decisions using mathematical models.